there's one more type of function that we haven't covered, recursive functions. So let's do that now. They're not abysmal. They're actually quite fun once you get used to them. So go ahead and get into a new Colab notebook. Alternatively, you could use another one of the functions notebook and just make a subheader. Okay, it's not like you've always got to do it how I do it. Either way, get a notebook titled recursive function or a subheader in another notebook. Okay, the point here is that you can make your notebooks your own and order them in the way that is best for you. Okay. Okay, so what are recursive functions? Well, I would like to use an example to look at one. And I'm going to do a text cell first to show you. So double clicking does not often work for me. Okay, so have you guys seen like 5 factorial? I know some of you probably have and some of you haven't. This is a mathematical meaning, and the meaning is 5 times 4 times 3 times 2, times 1, which in this case, that would evaluate to 5 times 4 is 20, times 3 is 60, times 2 is 120. Okay, and so factorial is something that you know is nice. It's a nice example that we can use to create a recursive function. So let me show you how that's done. Let's just jump right into it. So write recursive function, say factorial. That's what that symbol is called, the exclamation in math. Factorial recursive function. In case you're wondering, you see that in probability, and you also see that in Taylor series and calculus. So let's start it together, okay? DEF, right? We know that, and we call it something like factorial. And then what's the input? The input's going to be a number, okay? Call it num for short if you want. And then there are different ways you can do that, right? Because if you start with 5, well, you know, you can imagine this could be a little tricky, like to actually code straight. It's actually really nice to do in terms of a recursive function. So let me show you how to do it. Okay, if num is equivalent to 1, we're going to go ahead and return num. Okay, right? 1 factorial is just 1. Else, this is the recursive part. We're going to return, okay, num times, so like I say, it's 5. 5 times what? We do it again. Factorial, not num, which is 5, but we change it to num minus 1. Okay, so this is why it's called a recursive function. It's so cool. Look at this. We're defining the function here, but within the definition, we are calling it. We're calling the function there. Okay, so what should happen? Like, let's just say it's 3 factorial. Okay, well, so if we put in 3 here, well, 3 is not 1, so you go here. Return 3 times the factorial of 2. Well, 2 is not 1, so again, jump down to else. Return, see, it's already 3 times, so now it's going to be 3 times what? 2 times factorial of 1. Well, that is 1. So now we're just going to return, oh my gosh, I think I did something wrong here. I want to say num, but we're not returning 1. Well, it's because we're in this long sequence of returns. Let's just try it. Okay, so we press shift enter to run the function. And let's try factorial of 3 and see if it works. It does actually work and give 6. It's kind of tricky to explain, but we could try it again. If I try factorial 5, I did not spell it correctly. And look, when it says name not defined, Factorial, that, you know, and it's underlined, that's a clue that you wrote it differently. Factorial has not been defined, factorial has. Okay. Press shift enter again, I do get the desired 120. So, I mean, I was even paused on it a little. Let's just look quickly at this example with the factorial of 3. What happens, right? So, you know, round 1, get this 1, 2, 3 thing going. what happens? You return 3 times factorial 2. Okay, so that's the return. But then when you get factorial 2, this is going to then equal something. So we can substitute in, okay? What does that equal? 3 times, well, factorial 2 is not 1. It's so you return 2 times factorial of 1. So factorial 2 becomes 2 times factorial 1. And then what does that become? Well, when you're on factorial 1, 1 is equivalent to 1, it becomes 1. So the final step, you get return, you just substitute everything in because it's the first return. 3 times 2 times 1. Okay, that's a recursive function. Think about adding it to your toolkit. It's particularly nice for factorial. And, on occasion, you'll see other good examples for it. Job well done.